we need to find the current I naught. We can see that there is a current dependent voltage source here which is 10 I naught, and the current here is I naught. So we will apply loop current method to do that. There are 3 loops and 3 loop currents are already assigned. So we need to write the loop current equations for each of the loops. So basically this is the drop for I1, and then I can write the drop for I2, that will be this way, and then the drop for I3 will be like this one because the currents are all counterclockwise. So if I write the equation for the KVL equation for loop 1, which is this one, I will first write the voltages for I1 minus I3. This is a drop in the 4 ohms resistance. Then 2I1 minus I2, this is the drop in the 2 ohms resistance. And on the right hand side the voltage rise, which is 16. So basically this is 4I1 plus 2I1 minus 2I2 minus 4I3, that's 16. So 6I1 minus 2I2 minus 4I3 is equal to 16. That is equation 1. Now I want to make an observation here, and we will be able to write this equation directly if we follow that method. So basically we can see that this one directly. So it is 6I1. So basically the current for which we are writing the loop equation, I mean the loop current. So we are writing the loop current equation for I1, and I1 will have the sum of all the resistances. So the voltage drop due to I1 will be the sum of all the resistances. So basically here 4 and 2, and the other currents will come as a negative, and only the resistance that will be multiplied with those currents are the one that is the connecting resistance. So basically here for I2, the resistance that is common with both I1 and I2 is 2 ohms, and that one is coming with the I2 as a negative. Similarly for I3 we can see the common resistance is 4 ohms, so that is coming as negative 4I3. So I will write the equation for the second one, loop 2. So that is, the drop is, so 2I2 minus I1 plus the 8 ohms resistance, so that 8I2 minus I1, and if I go there, this is a rise here. So on the right hand side it will come as a positive, so that's 10 I naught. Now we know that I naught is I3 because this current is I naught in this direction and the loop current I3 is there. So I naught is I3. So we want to get rid of I naught. So we will just write I3. Now before we do that, from here we can write minus 2I1. Then all the I2s are added. So 8 plus 2, that is 10 I2. And then minus this one should have been I3, sorry. So this is 8I3 and this is 10I3 now. So here again 10I2, because we are writing the equation for I2, and the sum of the resistances that it has, this loop has, is 8 and 2, so that's 10. And when we are writing I1 it will be minus 2I1, and when we are writing I3 it will be minus 8I3 because 8 is the common between I2 and I3. So that's, we can write directly, we could have written directly. So this one I am writing just 10I2, and this 10I3 is coming here, so it's 18I3 is equal to 0. That's equation 2. Now equation 3 I will write directly, so that's 4 plus 6 plus 8, that will be 10 and 8, 18. So that will be 18I3, which should come as a positive. Then negative 4I1 here, negative 4I1 and negative 8I2, and this is plus, so this should be is equal to 0. This should be the third equation. So I have all the three equations, this one, and here is this one. So from these three simultaneous equation, I have written the equation in as per Cramer's rule in matrix form, and then the equivalent determinant. So the determinant is like that, and since I am interested in finding I3, just the third column has here I3, the right hand side. So now the determinant has to be calculated, so I have done it. What is the rule is finding determinant 6 times this minus this times this, then negative of this, and then this times this and this times this minus, and finally plus this, and then it goes this times this minus this times this. So basically that's what I have done here. 6 times 10 into 18, so when it's 6, 10 times 18 minus 18 times minus 8, and then negative 2, but the equation also has another negative, so that one, and then minus 2 times 18 minus 18 times minus 4, so like that, and then finally minus 4 there, so minus 2 times minus 8, and then minus 10 times minus 4, so minus 2 times minus 8 minus 10 times minus 4. So that is in the denominator, and in the numerator there are few zeros. So basically when I'm doing 6, these two and these two are multiplied, so these two are 0, gone. Then negative 2, this one times 0, this one times 0, so this is also gone. Only 16 will be there, so this is the value 16. So with 16, minus 2 times minus 8, which is minus 16, minus 10 times minus 4, which is minus 40. So minus 40 minus is plus 40, so that's there. So that in the denominator what happens is these two gets cancelled, the same. So we have finally 16 times 2, 16 times 56, and in the denominator 4 times 56, that's I3. So basically I'm just calculating the value of the determinants, numerator and denominator, so it's negative 4 ampere. So that's the current I3, and I3 is I0, so we are interested in finding I0. Since I0 is I3, that is 4 ampere, so basically I0 is 4 ampere.